This is the first review tape in intermediate algebra. In this tape, we're going to go over examples on order of operations, do some work with polynomials, and some examples about factoring. This is just a review. We're going to just be going over examples. If you find that any of it's going a little too quickly for you, then by all means go back and look at the original videotape lessons. Okay, this is just to work out some examples, give you a final review. As our first example, we're trying to evaluate this expression here. We have parentheses, brackets. Looks sort of complicated. The important thing here is to keep in mind order of operations. Okay, for example, you just don't start jumping in and saying, well, 8 minus 4 is 4, or 5 minus 2 is 3. You have to think of order of operations. In particular, what does this mean? We're going to do our multiplications and divisions before our additions and subtractions, unless there is something to, unless a grouping symbol, okay, sort of counters that order. Let's see what we're talking about here. Let's work inside. First, we'll take care of what's inside the grouping symbol. Let's look at this bracket in here. We have 5 minus 2 times, in parentheses, 3 minus 5. Okay. We do not go and say 5 minus 2, that's 3. First, we say it's 5 minus 2 times something. This multiplication will occur before we subtract from 5. Okay, now, as I said, ordinarily, we do our multiplications and divisions before additions and subtractions, unless something is in a grouping symbol and it gets handled first. For example, 3 minus 5 is in a grouping symbol. This means that this subtraction will have a higher priority, and we're going to handle that first. Okay, so let's just do a little bit at a time here. We have 8 minus 4, 5 minus 2. Okay, 3 minus 5, that's minus 2. So we're going to have, we're just replacing now 3 minus 5 in that parentheses by minus 2 in parentheses. We realize that this multiplication comes before the subtraction. So we don't go 5 minus 2 is 3. Instead, we say minus 2 times minus 2, that's plus 4. 5 plus 4 is going to give us a 9. Okay, let's see what we have downstairs. Once again, resist the temptation to say minus 4 minus 6, that's minus 10. Realize that we have minus 4 minus 6 times minus 3. This multiplication comes before the subtraction. So it'll be minus 4 minus 6 times minus 3 is plus 18. Okay? In the denominator, minus 4 plus 18, of course, that's plus 14. Now upstairs. Okay, we're still inside this grouping symbol here. 8 minus 4. 5. Now, minus 2 times minus 2 is plus 4. 5 plus 4 here. Okay, 5 plus 4, that's 9. Okay, it would have been entirely different if you were to subtract and get 3 times minus 2. You do the multiplication before that subtraction. 8 minus 4 times 9 over 14. Once again, do not make this 4 times 9. Do not do subtraction. Realize that this is 8 minus 36. First, you do the multiplication, 8. So you have 8 minus 36 over 14. 8 minus 36, that's minus 28. Minus 28 over plus 14 for a final answer of minus 2. For our second example, we want to evaluate the following expression: xy squared minus x times y quantity squared minus in absolute value x minus y if x equals minus 3 and y equals minus 2. We want to substitute in those values. Every time you see an x, we're going to write a minus 3. Every time we see a y, we'll write a minus 2. We will get an expression which we will then evaluate, much the same way we handled the previous example. The only thing extra here is first we have to substitute. Okay, xy squared. x is minus 3, y is minus 2, and that is to be squared. Okay, even though we didn't need parentheses when we wrote it as xy squared, when we throw in the minus 3 and the minus 2, we do need the parentheses to clearly indicate multiplications. Minus 3x times y squared. Take away x times y. X, that's minus 3, y is minus 2, whole thing squared. Take away x minus y, that's minus 3, take away a minus 2. Okay, now over here, you have to resist the temptation to say minus 3 times minus 2 is plus 6, because this is squared. In order of operations, when you have powers, they come first before the multiplications and divisions, which of course then precede the additions and subtractions. Remember, this is minus 3 times minus 2 times minus 2. The minus 2 is squared, and then times the minus 3. So we get minus 2 times minus 2 is plus 4. So we have minus 3 times plus 4. Not, for example, if we had made this plus 6 squared, that would be 36, and what we really should have, of course, is minus 12. Take away. Now minus 3 times minus 2, that's inside the parentheses, so that gets handled. First, minus 3 times minus 2 is plus 6, which is to be squared. Take away. Now, you just don't start dropping all the minus signs. That's not what we mean by absolute value. First, evaluate the expression inside the absolute value, come up with a number, and then we'll take the absolute value of that. Minus 3, subtracting a minus 2, it's like adding a plus 2. So we have this. Minus 3 times plus 4 gives us minus 12. Plus 6 squared, that's plus 36, and we're subtracting 36. Take away the absolute value, minus 3 and plus 2, that's minus 1. So we have minus 12 and minus 36, which gives us minus 48. Take away the absolute value of minus 1 is plus 1, so we're going to take away a plus 1, minus 48 minus 1, for a final answer of minus 49. For our next example, I'm going to give you a polynomial. Five x to the fourth minus 3x squared minus 6x y squared plus 3. I want to find the degree and coefficient of each term. And also the degree of the polynomial. Okay, this polynomial is formed by adding together 4 terms, and they are 5x to the fourth minus 3x squared minus 6xy squared and plus 3. These are the terms in the polynomial. Now we're interested in the degree and the coefficient of each term. Let's put here coefficient and degree. Okay. Coefficient. You can think of each term as being composed of, say, a variable part and a constant part, and the coefficient, this is this constant that appears in the term. So we have here plus 5, minus 3, minus 6, and plus 3. These are the coefficients. Now we need the degree of each term. Well, first of all, let's worry about this case of the constant term. Constant term, we say that that term has degree 0. Find the degree of a constant term to be 0. In all the other cases, we're going to say that the degree of the term is equal to the sum of the exponents in all the variables. Add up the exponents in all the variables in the term, and that'll give you the degree of the term. Well, here the only variable is x. We have x to the 4th power. So the degree is 4 for that term. Over here, one variable as well. X is to the 2nd power. The degree of the term is 2. But here we have two terms. Two variables, x and y. X is to the 1st power, and y is to the 2nd. We add up the powers, the variables, 1 plus 2, and we get degree 3. The sum of the exponents in all of the variables in the term. Okay, now finally, what is the degree of the polynomial? The degree of the polynomial is the degree of the term of highest degree. If you look over here, the term of highest degree is this one. Its degree is 4. So the degree of the polynomial is 4. This is also the degree of the polynomial. The degree of the term of highest degree. In our next example, I want you to perform the indicated operations and simplify. Okay, just to shortcut, we'll just say simplify, but it means to perform all of the indicated operations and simplify the following. Minus 3x cubed plus 4x squared y minus 2xy plus 2 times x cubed minus xy minus, in parentheses, x squared y minus 5x cubed. Okay, now the first thing I'm going to do is to go through. We're going to remove parentheses using the distributive law. First, I will distribute 2 through this parentheses. And here, this minus before the parentheses, it's like distributing a minus 1 through the parentheses. Now let's see what we get. Minus 3x cubed plus 4x squared y minus 2xy plus, now distributing the 2, it'll be 2 times x cubed minus 2xy. And now distributing the minus 1, minus x squared y minus 1 times minus 5x cubed give us plus 5x cubed. Now we're going to collect like terms having exactly the same variable part. Okay, we notice that there are a few terms that involve x cubed. We have minus 3x cubed, we have plus 2x cubed, and a plus 5x cubed, for a total of 4x cubed. And we've taken care of the terms involving x cubed. All right, now let's look at this next thing, the x squared y terms. We have a 4x squared y there, and a minus x squared y there. Combining those, plus 4x squared y minus 1x squared y for plus 3x squared y. And then we have two terms, both involving xy, minus 2xy and a minus 2xy, combining to minus 4xy. Like so. In the next example, I also want you to simplify an expression. And here it is. 3x minus 2 times x squared minus 4x minus 8, in parentheses, take away x minus 4 squared. All right. What we're going to do here is use the distributive law. Think of this as sort of like a plus b times c. We'll make it a times c plus b times c. We're going to make it 3x times x squared minus 4x minus 8. Think of that as a single quantity here. And then minus 2 times x squared minus 4x minus 8. The 3x times this minus 2 times this. Take away. Now here, be careful. There are no shortcuts. You can't simply say this is x squared minus 16 or x squared plus 16 or anything like that. This is, of course, x minus 4 times x minus 4. It's x minus 4 squared, so that's going to have to be worked out. This will be done by the FOIL method, which is just basically repeated use of the distributive law, because it's 2 terms times 2 terms. And here we will distribute 3x through the parentheses. 3x times x squared gives us 3x cubed. 3x times minus 4x gives us minus 12x squared. 3x times minus 8, that's minus 24x. Now minus 2 to be distributed through these parentheses. Minus 2x squared. Minus 2 times minus 4x, that's plus 8x. Minus 2 times minus 8, that's plus 16. Take away. And I'm first going to square it. I'll worry about the actual subtraction later. Let's just square this out using FOIL, x squared. First, outer and inner, minus 4x and minus 4x, that's minus 8x. Last, minus 4 times minus 4 is plus 16. This is, of course, like having a minus 1 here to be distributed through the parentheses. As we're going to change the sign of every term in here. So let's see what we have. Let's just rewrite this. 3x cubed minus 12x squared minus 24x minus 2x squared plus 8x plus 16. And now, minus 1 times x squared is minus x squared. Minus 1 times minus 8x is plus 8x, and then minus 16. Now we're looking to combine like terms. Okay, we have only one term involving x cubed, this first term here, 3x cubed. Now let's see what we have for x squared. We have a minus 12x squared, a minus 2x squared, and a minus 1x squared. Minus 12 and minus 2, minus 14, minus 1, minus 15x squared. Okay, now let's look at the terms involving x. We have a minus 24x, a plus 8x, and a plus 8x. So minus 24x plus 8x, that's minus 16x, plus 8x gives us minus 8x. And finally, we have a plus 16 and a minus 16. Those are the only constants, and they knock each other out. So our final answer is 3x cubed minus 15x squared minus 8x. In our next example, also I want to simplify as much as possible the following expression. 2x squared minus 3 cubed, take away 3x squared times 2x cubed minus x. Now, this 2x squared minus 3 cubed means 2x squared minus 3 times itself 3 times. It's a factor 3 times. Now, over here, what do we have? We have this times this times this. Now, some people, when they learn the distributive law, get carried away. They just sort of like to distribute everything. I want you to understand that if this had said 3x squared times 2x cubed minus x. This had been 3x squared times 2x cubed minus x. In other words, we didn't have the parentheses here and here. This would mean this times like a times b plus c. We would have to distribute it. This would be 3x squared times 2x cubed minus 3x squared times x. And we would have had 6x to the 5th minus 3x cubed. Okay, but this is different. It's this times this times this, and we do not distribute the 3 or the 3x squared. We don't say 3x squared times 2x cubed and then 3x squared times minus x. If you're multiplying 2 times 3 times 4, this is 2 times 3, that's 6 times 4 is 24. You don't say 2 times 3 and get 6 and multiply that times 2 times 4. That would be 48, and that would be too much. Okay, this is not to be distributed. This is different from 2 times 3 plus 4. This is 2 times 3 plus 2 times 4. Here you distribute, here you don't. You just keep multiplying and keep your product. Okay, let's go back over here and see what we have. We have like minus 1 times 2 times 3, just taking care of the coefficients first. Minus 3 times 2, it's minus 6 times minus 1, so it'll be plus 6. Minus 3 times 2, minus 6 times minus 1, plus 6. Now as far as x, it's x squared times x cubed times x to the first. All right? X squared times x cubed times x to the first for a total of 6x to the 6th power. Now, FOIL can only be used with a binomial times a binomial. So what we're going to do is, this we can do. We can't do anything here. We can at least use FOIL to combine these two. First, 2x squared times 2x squared gives us 4x to the 4th. The outer is minus 4x to the 4th. The outer is minus 6x squared. The inner is minus 6x squared. That's minus 12x squared. Minus 3 times minus 3 is plus 9. 4x to the 4th minus 12x squared plus 9. And at the end we have this plus 6x to the 6th. And here we're going to use the distributive law. Again, we're going to say this is like a plus b times c. A times c plus b times c. Or 2x squared times 4x to the 4th minus 12x squared plus 9 minus 3 times 4x to the 4th minus 12x squared plus 9, and then plus 6x to the 6th. 2x squared times this minus 3 times the same thing. Now we'll distribute the 2x squared, giving us 2 times 4, 8, x to the 6th. 2 times minus 12, that's minus 24. X squared times x squared is x to the 4th. 2 times 9, 18, x squared. Now distributing the minus 3. Minus 3 times 4x to the 4th, that's minus 12x to the 4th. Minus 3 times minus 12x squared is plus 36x squared. And minus 3 times plus 9, minus 27. And plus 6x to the 6th. Now we would like to combine the like terms. Let's see what we have for x to the 6th. We have 8x to the 6th, 6x to the 6th, for a total of 14x to the 6th. Let's see what else qualifies like terms. We have minus 24x to the 4th, minus 12x to the 4th for minus 36x to the 4th. 18x squared and 36x squared for a total of 54x squared. And then finally, one constant, minus 27. Final answer, 14x to the 6th minus 36x to the 4th plus 54x squared minus 27. Having spent some time multiplying out polynomials, we'd like to sort of now reverse the process and go over some examples involving factoring. Okay, given a polynomial all multiplied out, can we go back and find the factors? Okay, so in each case I want to factor as completely as possible. The next example is problem 7. We have 12x cubed y to the 4th minus 4xy cubed. The first thing in any factoring problem is to look for a common factor that you could possibly pull out. Okay, and here, first you look at the coefficients. You see the 12 and the 4, and the most you can pull out that's common to both terms is a factor of 4. And you look for, let's say, the next variable x. You see x cubed and x to the first power, and the most they have in common, the most you can pull out is the x. You have y to the 4th and y cubed, and the most you can pull out is the y cubed. And then you look to see what would be left in each term having pulled that out. So over here, you say from 4 to 12 you have 3. X multiplies by x squared to give you the x cubed, and you need a y to get the y to the 4th. This would give you 12 x cubed y to the 4th. Take away. Now what's missing here? Nothing. You just have to multiply by 1 to get that. You multiply this out using the distributive rule, you get exactly that. In our next example, I want to factor x squared minus 12x plus 20. Now we look for a common factor, and there's nothing other than 1. We look for a common factor over 1 that we could pull out, and the only common factor is 1, so we ignore that. And what do we have here? We have a trinomial, and we think that maybe we can factor this into the product of two binomials. The following form, put an x here and x here. And sort of thinking back how FOIL works and working in reverse, we would like to find two numbers to put here, whose product would be the plus 20, and which would add to the minus 12. Two numbers which multiply to plus 20 and add to minus 12. And of course, without thinking too much, you get minus 10 and minus 2. We check this by FOIL, giving us x squared minus 2x and the minus 10x minus 12x plus 20. Now the next example starts off similar. It's x squared minus x minus 20. Once again, there is no common factor other than 1 that we could pull out. We're going to try the same kind of procedure. Two numbers which multiply now to minus 20 and add to minus 1. Okay, multiply to minus 20, that means one's going to be positive and one's going to be negative. They're going to add algebraically to the minus 1. Okay, and what comes to mind is minus 5 and plus 4. Okay, giving us x squared plus 4x minus 5x is minus x, and then the minus 20. You should note that if the last term here is positive, that means either you're going to have two positives or two negatives here. So in a sense, well, there'll be, for FOIL, you'll have terms that have the same sign. You'll have minus 2x to minus 10x. You'll be adding terms with the same sign, and of course, we traditionally think of addition, whereas here we're going to be adding, since the product is minus 20, one's going to be positive, one is negative. For FOIL, you'll have a plus 4x and a minus 5x. When you add algebraically, it's basically a kind of subtraction, and you get the minus x. But still, I mean, if you can think of it algebraically, you want two numbers which multiply to this constant and add to the coefficient of the x term. In our next example, we have 4x squared plus 20x plus 24. Okay, now although it's a trinomial, we're not going to jump right in and start to try to break it into two binomials. The first thing we always look for is a common factor, and this one does have something other than 1 as a common factor. It has 4. You can factor it out. You get 4 times x squared plus 5x plus 6. And then this we will factor in the traditional way, looking for two numbers which multiply to plus 6 and add to plus 5, and of course, that would be plus 2 and plus 3. It would be much more difficult if you tried to factor it in this form. In our next example, we want to factor 3x squared minus 17x plus 10. What makes this problem different from all of the other ones is that in all of the other trinomials which we tried to factor, either the lead coefficient was plus 1, or it was plus 1x squared, or there was a common factor that you could pull out, leaving you with plus x squared. Whereas the trinomial that you were working with had just 1x squared to start off. Now we have the 3x squared. What this means basically is we have more possibilities because we have to consider not only that the last terms have to multiply to plus 10, but the first terms have to multiply to plus 3. Now this is not particularly terrible because 3, is only 1 times 3 or 3 times 1. If it were a number like 12, you'd have to consider all the various ways that one could make 12 here, as well as the ways that you could make 10. Okay, still, you can make a bit of a chart to help you on this. You can list over here, say, the different ways to make 3, say 3 times 1. And on the right of the line, different ways to make 10. For example, 10 times 1 and 5 times 2. And to cover the different possibilities, considering the 3, it could be 3x and 1x here, or 1x and 3x. Okay, on one side, we reverse the possibilities. We can just arbitrarily reverse them on this side to consider all the different versions. And what we're basically going to do here, since the only possibilities are 3 and 1, we're looking to figure out what goes in here. It's a trial and error kind of procedure, trying to figure out what numbers to put here so that the FOIL should work out to that when you multiply it out. Okay, now, the product is plus 10 here. Whatever goes here and here, they have to multiply to plus 10. So either it's going to be 2 positives or 2 negatives. Now, if it's 2 positives, let's figure that out. If it's 2 positives, and it stands to reason, and the outer and the inner will both be positive terms, which obviously are not going to add together to minus 17x. So we know that this is going to have to be a minus, and this is going to have to be a minus. Beyond that, we don't have to worry about. What we're looking for is, in other words, since they both have minus, we're looking to pick things which will add up to 17. We don't have to worry about the minus 17. Here's what we do. We say, in a sense, this is like an addition table. We want to add to get 17. We go 3 times 1 and 1 times 10. 3 and 10, they add to 13. That's not correct. We try 3 times 2, that's 6, and 1 times 5. 6, 5, they add to 11. That's not right. 3 times 10, that's 30, and 1 times 1, that gives us 31. That's not right. And the last one, however, 3 times 5 and 1 times 2 is correct. That's 15 and 2, 17. In other words, we would like to see the 3 multiplying the 5, the 1 multiplying the 2. Now 3 is on the outside, so the 5 is going to go on the outside here. And 1 is here, so the 2 is going to have to go in here. And if we check this by FOIL, we get 3x squared minus 15x minus 2x. It's minus 17x plus 10. Okay, let's try another one of those. 10x squared plus 19x minus 15. Once again, there is no common factor that we can pull out. Here, however, there are a variety of ways to multiply to get 10. We can't be sure it's a 2x and a 5x or a 10x and a 1x. We'll have to postpone that now. What we do know, however, is that the last terms multiply to minus 15. One is positive and one is negative, which means when you do the outer and the inner, you'll have a plus some number of x minus some number of x. So in effect, what we're talking about is a subtraction problem here. Whereas in the previous problem, when I crisscrossed looking for the results, I added them up. Here I'm going to subtract to try to wind up with the 19. Okay, now the ways to make 10, let's say 10 and 1, 5 and 2. ways to make 15. 15 and 1, and 5 and 3. And choosing to reverse, say, the right side here, 1 and 15, 3 and 5, to cover all the possibilities. We're looking for subtraction. Okay, we say 10 times 1 and 15 times 1. 10 and 15. It doesn't matter whether you consider it minus 5 or plus 5. We'll take care of that later. Basically, the difference, we'll think of it, the absolute value of the difference. Okay, so it's a 5. Here we have 30 and 5. The difference would be 25. Here, 150 and 1. It's clearly not 19. 50 and 3, also not 19. At this moment, we can now knock the 10-1 combination out of consideration. We move on to the 5-2 combination. 5, 30, difference 25. 15 and 10, the difference is 5. That's not right. 75 and 2, the difference is 73, not right. And finally, 25 and 6, the difference gives us the 19. Okay, it's always possible, of course, that you just can't do it. In other words, if none of them work, then maybe this thing does not factor in this form. Okay, and by the way, it doesn't always come out to be the last one. I'm not very lucky at this today. 5x and 2x. In other words, 10x will be made from the 5x and the 2x. The 15 is going to be made from a 3 and a 5. Okay, how should it be done? The 5 has to multiply the 5 to get the 25. Okay, so since 5 is on the outside of the 5, here we'll go on the outside of the 3. Now we'll worry about the sign. Obviously, 1 is a plus and 1 is a minus to give us the minus 15. But we want the outer and inner together to give us the plus 19x. So we'll put a plus 5 here and a minus there. 15x squared plus 25x minus 6x is for the plus 19x, and then minus 15. Okay, and I'd like to finish off this tape with 2 fairly simple examples, just to illustrate some other rule of factoring that you might have forgotten. 3x to the 4th minus 48x squared. I want to factor that completely. Looking for common factor, we see that we can pull out a 3, then x squared, leaving us with x squared minus 16. 3x to the 4th minus 48x squared. However, we're supposed to try to factor completely, and we can go a little further on this. X squared minus 16. Now, you can consider this the way we've been doing before, looking 2 numbers. You could think of this as like having a 0x in here, 2 numbers which multiply to minus 16 and add to 0, and of course they'd be plus 4 and minus 4. It's easier just to remember the rule for factoring the difference of 2 squares. This is like a squared minus b squared. It factors into a plus b times a minus b. And by FOIL, of course, we get x squared minus 4x plus 4x, so the x drops out, and then minus 16. And the last problem on this tape, I would like to factor completely x to the 4th minus 81. And we see this is a difference of 2 squares. It is x squared squared minus 9 squared, like a squared minus b squared. So we're going to have x squared plus 9 times x squared minus 9. A plus b times a minus b. Now, x squared plus 9 is as far as we can go, factoring over the real numbers, but we can do better on the x squared minus 9. It, too, is a difference of 2 squares. Therefore, it can be factored into x plus 3 times x minus 3. And that brings us to the end of this tape.